Righto, Hooke's law. So Hooke's law is all about strings and what we call elastic deformation. It's where things move. So torsion springs are your normal mousetrap. Compression strings are usually used for things like your valves and stuff in cars. Extension springs are our standard little trampoline springs. Tape springs are your measuring tapes, and leaf springs are your trailers. And you've seen all these things before, but today we're going to get into a bit of detail on how these things work. So Hooke's law essentially says that the spring, the force on a spring, has something to do with the distance, which we're giving x, and the force has something to do with the distance. And we've got this wonderful thing called K, which is a constant. And this depends on which particular spring you're using. And the way a spring stretches, it either stretches or compresses, and it follows this funky curve. I'll do it in green so you can see. And Hooke's law essentially works between this bit here where it's constant or linear. So you can see here it's compressed, it's not compressed. Here we're elongating it, we're pulling it out, we're drawing it out and drawing it out further. So why does it only work that far? Well, Hooke's law works between here and here up to the yield strength. At the yield strength, we start moving into strain hardening, which is where things start to move, and then you get to your ultimate strength. Once you get past your ultimate strength, if this is your spring, if this is a section of your spring, it will start what we call necking, where it starts to thin out, and eventually you get your fracture at this point here. So Hooke's law is about the opposing force. So all things have a weight, and that weight pulls them down, and the spring force is essentially pulling them back the other way. So here's a spring. This is a single spring, and it's moved at 25 mil. If we put two springs next to each other, it's going to move 50 mil. And the weird one is, if we do them in parallel, we actually only move half the distance. So two springs will only drop down our 12.5 mil. So here we go, we're going to get into a question now. So if a teddy bear has a mass of 400 grams and it's hung from the end of a spring. So we've got to start off with the easy part, which is working out the force due to gravity, F equals mg. So m is your mass, g is gravity. And we can use that to work out the spring constant. So let's have a quick look at this, and we'll go through it together. We'll do the calculations, and then you guys are going to do some all by yourself. So here we go. So we've got force equals mass times gravity. Now we're going to assume that gravity is 10 and our mass is 0.4. Remember, it was 400 grams, which is 0.4 kilograms. And what we're going to do is we're going to say that therefore 10 times 0.4 gives us 4 newtons. And that's our force due to gravity. So when we're looking at Hooke's law, we can say that F equals minus kx, and we're looking at the change in x. So from our question, we knew that we started at 51 and we went to 72. So the change is 21. So change is just shown as delta x. So delta is just a triangle, 21 millimeters. So whenever we do these things, we always work in meters, kilograms, and newtons. We always work in these units because they're our SI units. So what we can do is we can plug all our numbers in. We've got 4 for our force because that's the force due to gravity. We've got minus K, which we're trying to work out, which is our spring constant. And we've got 21 millimeters. So 21 millimeters is 0.0. Made a mistake. 21. So now all we've got to do is go through and do a little calculation. So we can say that K equals 4 divided by 0.021. We chuck this into our calculator and out comes our answer. So our K is minus 190. And that gives us our spring constant. So for the next activity, what we're going to do is we're going to do a simulated prac. And what we can do is we can drag our ruler over and pop our red weight on, and we're going to try and work out how big it is by working out the spring constant. And I'll show you that in another video. Lastly, once you've done your simulated prac, what you're actually going to do is you're going to find the weights of each one of those using your calculations in your spring constant, and then using the Google Slides. In the Google Slides, you've got a link here, and that'll take you to a Google form where you input your answer. Lastly, you've got 2 assigned worksheets. And that'll get you done for the day. Have a lovely day, lads.